Okay, so the way that it's set up visually here, DE plus EF has to be greater than FD, EF plus FD has to be greater than DE, and FD plus DE has to be greater than EF. That always has to hold true. Often what you're going to do when you're working through problems on this is you're just going to focus on the two smaller sides. So basically the sum of the two smaller sides must be greater than the third side. Okay, so if you have numerical values, just compare the two smaller sides to the longest side, and the sum of the two smaller sides has to be greater than the longest. And now here's what would happen if that was not the case. So if we had a length of 7 here, and let's say 3 here, and 4 here. If you were to find where these pieces intersected, would they enclose a space? If this side of 3 and this side of 4 intersected on a length of 7, all they're going to do is they're going to meet at that point. They're not going to actually enclose a space. So you can't have two smaller sides that are equal to the longest side. And what if we made one of these sides even smaller? What if we made this a side of 2 and we compared? We bring these down. Now, are they even going to intersect at a point on that longest side? No, there's no way they can enclose a space, and so it's impossible. So you have to make sure that the two shorter sides have a sum that's greater than the third side. So what that allows you to do is it allows you to identify some restrictions on given sides. Okay, so if you have this triangle ABC and you're told that, even though it's not drawn to scale here, BC is 18 and AB is 7. Okay. There's two possible cases for your third side. Your third side is either the longest side or it's not. And so if it was the longest side, at what point would this side AC stop giving you a triangle? At what point would it no longer be a triangle? At what value of AC do these properties cease to exist? Brennan? Yeah. So if this is 25, right at 25, it's no longer a triangle. Now it's too long. These sides of 7 and 18 will no longer intersect one another. Okay, so the upper limit on that value of AC is 25. So can it be 24.9? Yeah, it can be something smaller than that, but it just can't be 25. So as long as AC is less than 25, you're good. Okay, so that's one scenario. The other scenario is it's not the longest side. If that's the case, then what would be the longest side? In this figure, 18 would be the longest side, right? So at what point, if that were the case, at what value of AC would this stop being a triangle if the longest side was BC? Now it stops being a triangle at AC equals 11, right? Because once it's 11 plus 7 is 18, now this point A would lie right on side BC. So you know that it can't be 11. It has to be some value greater than 11. Could it be 11.1? Yeah, as long as it's some portion greater than 11, you're good. So this would be the restrictions for your sides. Now, it winds up being a really easy calculation for this, right? The lowest restriction is just the difference of the two given values, 18 minus 7. The highest restriction is just the sum of those two values, 18 plus 7. And it's always going to be the less than symbols in this order. So your third side has to be greater than the difference of the given sides, but less than the sum of the given sides. And that is the property.